Please welcome Aniket Saha.
Good afternoon, everyone. Thank you for joining us here. I'm going to talk to you guys today about what we are doing and why we are doing. Thaddeus, as well as others, have already told you guys about the technologies and the products we're building. I'll give more of a product perspective today. But first, how did we get here? About 3 years ago, I was approached by Jim and Keith to come in, basically look at Tenstorrent technologies and figure out how to transform that into products. Because we saw a market growing quickly, which needed high-performance compute. And Tenstorrent had very good scalable RISC-V processors. And over the last 3 years, we have taken those technologies and converted it into high-end IP. So what does the open ecosystem really need? You need to have very scalable performance, high-performance cores. You need the ability to add custom instructions. You need to be flexible. But those are some technology aspects of it. You need to innovate on the business side as well. One of the biggest things people are looking for right now is the ability to take your IP and build on top of that. Currently, if you look at ARM or other technologies, they don't give you that option. They don't give you the ability to add custom instructions. They don't give you the ability to modify the underlying RTL. So one of the things we have done is we have made sure we can transfer ownership if someone needs it. We can add the ability to customize if a customer needs it. If they want us to do the customization, we can do that. To realize this, there is a key thing that is missing. You need to have silicon to show that the IP works. And we are providing that as well right now. We've chosen RISC-V to be the underlying technology for our products because RISC-V satisfies all the requirements for an open ecosystem. It is freely available, downloadable. You can take it, modify, build on top of that, and it is just there. It has no boundaries right now. Often people ask me, what is the value of RISC-V? Is it cheaper? Is it more efficient? Is it higher performance? I think it's all of those, but the main thing is RISC-V gives you control. That is the biggest value prop of RISC-V. We are building our IP portfolio based on RISC-V technologies because of that. And to quote Jim, this problem we are solving is we are giving our customers the control that they are requiring. So we are solving for freedom, the freedom to innovate, the freedom to control your roadmap. But technology and products by itself are just one aspect of it. You need to innovate on the business side of things too. So I grew up in the ARM ecosystem. I've been in the IP business for more than 10 years now. And throughout my stay in ARM and other areas, I saw customers were wanting the ability to customize the underlying RTL, tune it to their end work case, tune it for specific workloads. And these things were not very easily done. So what we have done is we have changed our business model fully to basically make sure the customers can take and build what they exactly want. Because we are, after all, a small company. We have multiple product lines, but we can't do everything that our customers want us. So what we do is we have a portfolio of products which are very high performance and scalable. We deliver that to our customers. If they want to take that and build on top of that, we provide that ability to do that. RISC-V obviously gives you the chance to customize the ISA if you want. If you want to add custom instructions, if you want to add custom processors, tightly coupled or loosely coupled, all of that is enabled in our portfolio. And on the business side, we have no crazy restrictions. We are very flexible. Whatever you have been said no to, we will say yes to. We'll figure it out. So which markets are we playing in? We started as a data center company, right? We were targeting the infrastructure markets. But as we started to move along in our journey, we saw the automotive market. There was a very organic pull for us. We started getting design wins in the automotive space. And over the last 3 years, one interesting thing happened. The robotics and automotive markets have kind of converged with the robotics requirements, which Thaddeus was mentioning, are the superset of the automotive requirements. Thanks to geopolitics, the other market that has become a very key market for us is sovereign compute, where nation states are wanting digital sovereignty. So we provide IP products for these markets, but these are not the only markets. These are some of the main markets. Some ancillary markets that have popped up is owing to the fact that we can cut down our IP based on our customer requirements. For example, a niche market in high-frequency trading uses ASICs. They require very high performance cores. They want to reduce the latency of every transaction. They don't need virtualization. They don't need vectors. What they do is they take our cores, they cut it down to the bare minimum that they want, and they can build using that. So we are seeing a lot more additional markets pop up, but these are our main markets right now. The commonality between these markets is all of them need high-performance computing. They need the ability to differentiate silicon. They do not want to have a software lock. They want to innovate themselves. And in the robotics and infrastructure market, another interesting thing is happening is the functional safety requirements are converging. When I first started in this IP space and I was driving ARM's automotive product lines, I was seeing people were wanting functional safety features which were there in the servers markets. So the automotive IP was starting to look like servers. But now it has come full circle. Server customers are coming in saying, you guys added certain features in your automotive or functional safety IP. We want to use those and add those into the server side of things. So it's kind of interesting to see how features which were once pulled in from server into automotive, from RAS, et cetera, are now going back from the automotive side into the server's end. And there's a reason for that, as Thaddeus mentioned. You need a continuity from the edge to the cloud. Every automotive company is actually having a server backend. So you need to have that digital continuity. So these are a couple of markets we are playing in. And our IP portfolio has 5 basic underlying things that we are focused on. One is our designs are based on RISC-V, so it's open source based. We are the only IP company that we know of who has compute as well as training and inference IP available right now. All of these technologies and products are silicon proven at the time of release. All our IP is scalable and configurable. Business models are flexible. One thing I will like to say is we are focusing mostly on the high performance end of the spectrum. This lift is very heavy. We cannot do everything ourselves. And this is why we partner with the likes of Arteris, Baya, Core Lab, our partners who work with us to create fabrics, to create functional safety technologies, to create high efficiency IP and SoCs. And you'll see more about that in the future. But our overall strategy is to build a autonomous distributed ecosystem where it's a functionally safe ecosystem. We're not just building functional safe products. There is no point of failure in the ecosystem if we go down this route. Looking at our IP portfolio, some of you, these have been talked about already, but 4 main product lines. CPU IP is where we started. We quickly came back with AI IP. When you're running IP product lines, you look out for a couple of things. One is repeat customers. We recently got our first repeat customer. We have system IP, which is combined with all our products. That enables us to build out the entire SoC ecosystem, and you do not have to go to any third-party vendor for proprietary IP. The way we constructed our IP, we basically looked at what our customers were doing and how to migrate from a closed ecosystem to an open ecosystem. Our RISC-V Ascalon processors, all the interfaces are what you're used to. The coherent and the non-coherent interfaces are based on what you're used to from ARM right now. So you can do a hot swap or a rip and replace if you want. So from the get-go, we decided we are going to go up against the very best, and that's why we took this strategy. Thaddeus has already mentioned we are also building subsystem IP because we saw some of our customers are struggling to integrate things together. So what we do is we solve some of the customer problems before it arises. We give you CPU IP, which is not just a core by itself. It's a cluster which has all the system IP integrated already. So fully verified, validated drops are provided to you at the get-go. We provide you with all the system IP collateral, fully verified, validated. It comes free with your CPU IP. You don't have to license that separately. And in the future, we'll open source a lot of that. We are already open sourcing a lot of that already, but stay tuned for more to come. In a temporal context, if you look at our system, our products right now, first generation, which is available now, is Ascalon CPU IP with the system IP to build out large core clusters. We're following that with the functional safe IP. You guys who are following us know we recently acquired Blue Cheetah, which gives us the die-to-die IP. This will enable us to build out large-scale systems, both scale up and scale out. On the AI IP side, we are already on our second generation AI IP. That's coming out in silicon right now. The third generation will have automotive support. And the final thing I'll point out here is we are very happy to see Atlantis, which is a partnership with our friends at Core Lab, building out 8-core cluster Ascalon-based development vehicle, highest performance RISC-V platform that we are aware of right now. And next generation onward, we will move on to higher performance, higher efficiency, but we won't go in there right now. Taking a look at Ascalon, when we started, our target was 18 spec in 2K6 per gigahertz. Currently, we are at 21. Yes, we overshot our IP targets, but we are also running a bit late. But Jim told me, hey, don't worry about this. Our job is to make sure we turn the impossible late. So we are running late, but we are getting there. RVA23, fully out of order, 8 wide out of order, 2.5 gigahertz, great specs. When I first joined Tenstorrent about 2.5 years ago, this seemed like a pipe dream. The fact that RISC-V would scale up to leadership performance. And if you look at it, ARM Neoverse V3, we are neck to neck with that. That took ARM a dozen plus years to get there. We got there in 4 years. Of course, it was late, but we're just getting started. One last point here, this is available right now. Multiple customers are evaluating what we have. You have various options to evaluate if you want, and I'll talk about that in a couple of slides. As my friends across the pond always say, the proof is in the pudding, and they want to test it out before seeing what we are selling. If you want to test out, I welcome all of you. We have various form factors that you can use. You can use 10.6 in cards that are available, or in a developer kit, or in the cloud via our partners. We recently open sourced Polaris, which is our first open source simulator. This enables you to take your models, optimize them, and see how it will run on our architecture. And then you can get a better feel for what configuration of the IP would work for you. We have links here to GitHub, which will point you to our open source stacks. But all of this would not be available if there was no RISC-V. All our IP is inspired by RISC-V. 10.6 IP, not a very well-known fact. There's 5 baby RISC cores in there. In the future, we might open source those cores as well. Similarly with Ascalon, if you want to evaluate Ascalon, don't take our word for it. We have providing access to Zebu Cloud as well as HAPS right now. Upstairs in a demo room, you will see we have Doom running on HAPS. Of course, if Doom doesn't run on it, it's not real. So that was our benchmark. There was silicon missing. We are building out our silicon right now. As I mentioned, it's going to be available in Q2. And we are seeing a tremendous pull for Atlantis right now. Lots of customers, OEMs, tier ones are waiting to get access to this. We initially were thinking of just building a development platform, but we changed to product spec because of the demand. So if you guys are interested in Ascalon, you know who to reach out to, first.last@tenstorrent.com. Me and my sales team would be very happy to take your calls. Thank you.
Well, that was informationally dense. Was it? Did we share a few things? I was trying to count the number of products and IPs and boxes, and I gave up. I don't know how many there are. We're going to have to do a retrospective on that and count them up. And also, this will be available as video with an LLM that lets you interpret everything. And then there was 2 things before I talk about this slide. One is, Aniket said, no crazy licensing terms. Do you know how many times I've wanted to take an IP I bought and make a small tweak, an RTL change to hit your performance target? How many times I asked ARM for an accelerator port, be able to add a simple instruction. With RISC-V, you can do it, and with Tenstorrent, you can do it. You want to modify it, that's a license. Keith has an idea, he calls the innovation license it, change it all you want, right? Roll your own adventure. I think IP should be built that way, right? If you make big changes, it's on you to go verify it. But we're also providing the tools to do that. I think that's really important. So we're building a full stack, right? We talk to lots of people. My investors call me up because I spend too much money. And they're like, can you focus on something? Well, AI is wild. It goes from really little to really big. Image, inference, or language, stable diffusion, which has got everything, right? Training, inference, it's so diverse and it's still changing. I don't want to be the guy that did a targeted LLM chip taped out like 1 month after a new model came out that blow LLMs out of the water. That's going to happen, by the way. So if you're doing an LLM-only chip, personally don't think that's going to work. There's a lot of innovation going on. So there's a generality to the platform that's really important, right? And a breadth to it. And I want to make AI and RISC-V successful, lower cost, more available. And so we decided to invest CPU, AI, software systems, training. We support and license everything we do. Our strategy is open source software, open source support IP. We do high-end CPUs and AI that we license. We sell chips and servers. Next year, we're going to start to sell chiplets. It's going to be great. I really want to make the next generation of computing much more open. I want to build things faster. I want to make it more fun. And the AI tools are really cool. Just think about having an IP that works, that's composable, a chiplet framework, and support IP that already works so you can do your job, right? And put it together and verify it faster and build it faster. Like, we're really doing this. We did an event earlier this year. I got the whole company together. We called it TT Together Day. And everybody's like, what do you want to get out of it? And I said, a team photo. So whenever I can, I show the picture. And I'm told this is the biggest version of it we've ever had. We have a lot of people working here. You just heard about a lot of stuff. One of my missions for Tenstorrent, it's a large number of small independent teams that collaborate. To be honest, I don't actually know what they're all up to anymore. I learned some stuff today. I was impressed. These guys are really doing a great job. And to make the platform work end to end, it's a lot of work, right? And then it's way bigger than Tenstorrent. We're really into having partners. We have some really good partners already. They're building chips, systems, CAD tools, technology, IP, software, models. And they get to work with all these fun people. And I encourage everybody here, part of the thing about open source is great is we publish our software, we publish a lot of RISC-V stuff. We're going to publish a lot more on our open chiplet architecture and all the collateral that goes with the system IP. And that's the team get to know their partners in the community. And we're really interested in people who want to contribute back, and we'll support you. I believe this is an open hardware revolution. People have talked about open hardware for years, and it's making progress here and there. But we want to take it to the next level. And there was a lot of pieces. There's lots of reasons why open hardware hasn't worked. It's too expensive, it gets incompatible. There's so many things to it. But the RISC-V guys have done a great job leading the RISC-V CPU architecture. There's still so much work to do there. We want to make an AI platform that many people can use, some from us, some from other people. So that's coming together. The chiplet stuff is really going to be game-changing. Like, I've talked to a couple of people who want to do a startup doing hardware. And if you have to license all the IP, do a physical design for all the IP that's already been done 10 times, you can't do it. $80, $100 million. Like, I want to get to the point where a startup can have a great idea, tape out a chip in a year for 20 million bucks. Tape out costs, PD costs, some licenses. Bring together PCI Express, AI, whatever pieces they need to go make a new solution. It's radical. So that's what we talked about today. RISC-V is way stronger, AI is stronger, automotive is stronger, open chiplet, Atlas. I love Atlas. Atlas holds up the world, right? And we want to work with everybody here to go make that happen in a really big way. So thank you very much for joining us today. And the LLM's coming.